Yeah, hi. Today we'll be exploring how to do meshing of a different of a curved surface or a curved domain. So as far we've explored how to mesh a rectangular domain, and that was easy. But to know um, why we do this blocking process, because it involves the blocking process, blocking mechanism, why we do it, why this blocking is necessary, that will be explored in this tutorial. So basically that will be focused on why we do this blocking, and we'll be doing meshing of a you can say a circular domain, or you can say you can consider a cylinder in 2D. So you can say like the cross section of a cylindrical of a cylinder. So to mesh that, and basically to construct or to mesh it, to generate a structured mesh that is focused on this topic. So let's assume that our cylinder has some radius, say anything you can assume for this tutorial. I'm gonna assume it to be the radius to be say 10 millimeters or 10 meters, whatever, 10 units, because I'm not specifying it here. I'm not specifying the units. I'll just say simply 10, and 10 means whatever I want that unit to be. I can fix this up in Fluent itself, the solver, when we do scaling. So initially some of the lectures will be focused on meshing only, and we'll solve later on. We'll simulate them. So this lecture is basically focused on meshing a cylinder, or you can say meshing a circular domain, a circle, meshing a circle basically. How do we construct a structured mesh into this circular domain? So let's assume our center will be an origin. I'm gonna select this XYZ coordinate system. Let me just put this up so that we can see all of these three coordinates. So because I'm not specifying in Z direction, so I'll be saying X, Y, and Z. And because we're gonna assume this to be this origin to the center to be an origin, so it will be 0, 0, 0. So I'll say apply. So now this is simply a 0, 0, 0. I have not specified any meters or millimeters or whatever. I can scale it later on in the solver itself. So I'm just creating in units, whatever it may be. I can specify it later on. So this is our center. Now I'm gonna construct a curve, or you can say a circle. So that is a curve. So I'm gonna go under this curve option, the second one, under geometry tab. So I'm gonna select this circle because I'm gonna construct the circle. So this is saying circle arc from center point and 2 points on the plane. But the thing is, I should be knowing the radius. I should specify somehow. So there's no option here in ICEM to specify the radius. So I'll have to construct some the point where this the circle will be passing, the circle's circumference will be going through. So I'm gonna go back to this point creation. I'm gonna select some radial point. You can see the point at circumference. That means I'm gonna say that to be 10 millimeters or 10 unit. Simply I can select x equal to 10 or y equal to 10, or simply any point you can assume over the circle of radius 10. So you can assume any point. You can create any point over the circumference. The best way, the easiest ones are, as per my understanding, you may simply say x equal to 10 and y equal to 0. Z of course will be equal to 0. Z we're not going to touch. So y equal to 0, x equal to 10. Or the other way, it can be x equal to 0 and y equal to 10. Whatever you may select. Okay, I'm going to just say y equal to 10. You may select the x equal to 10 and y equal to 0. So with this, I'm going to go ahead. So I'm gonna click over this apply, and I've got a point, but you can then see over the screen it may be hidden. So the best way is to fit the screen. This is the button to fit screen, fit window. So I'm gonna click over this, and I can see both of the points. So because y equal to 10 is basically greater than y equal to 0, that means this point is this one, the upper point, and this is gonna be our center point. And now let's go to here, this create modify the curves. Yeah, you may select one more point you can create, because this will require 2 points in the plane. But the thing you can say, simply see, look at here, this point. It is asking, it's saying circle or arc from the center point and 2 points on the plane. What are those 2 points? One can be this one that I created, and the third one may be any point over the plane, so that it can specify in which plane this circle is going to be there. Because if I select any other point in any other plane that can be rotated, let me show you somehow this Z. Okay, see, imagine this way also it can be done. So this is the center, and this is the point going over this circumference. So the best way is to switch to this Z plane or XY plane, you can say, and I'm gonna select this as a center point. This is the second center, the first point over the circumference, the point over the circumference, and any other point in this or this XYZ plane. If you click, the circle will be generated. Doesn't matter where you click the third point. So the third point may be clicked anywhere. I'm going to show you how. I'm going to click over this option, the third one. This is asking for the first one. First one was the center. Second is the point from where your circle is going to go. And the third one, anywhere in this plane, you just click. Now you can see I clicked somewhere, but this is going through this point. Now I'm gonna get out of this command by pressing middle button, and now my circle is ready. Okay, now this next step is to because our geometry is ready now, the second step is to block. So as I've told you earlier, go to this blocking tab, click over this block, create block, and now select this entity, select the geometry, click over this. Now it is asking select entities with the left button. So I'm gonna select this and drag and leave it left button. It will be created, it will be selected all this geometry, and click on middle button. Now you can see this is a block, and this is very much different scenario. As earlier you've seen that our domain was also rectangle and our block was also rectangle, but here you can see that it is containing this all of this geometry is touching, and this is the minimum sized block that is occupying all this geometry. So as we've discussed earlier also, now the thing is to create a mesh, mesh this domain. I'm not gonna go under creating different boundary conditions, as I've told you earlier also. I'm not gonna cover this scenario. This is completely based on meshing process. We'll be going through different boundary conditions in curved domains and set scenarios, curved geometries. We'll be doing these boundary conditions later on, but for the time being, I'm just gonna show you how to do this meshing, this type of meshing. Basically, this is a circle or an O that is called O, and why I'm calling it as O, that will be clear later on. I'm gonna show you how. The very first thing is to associate. I'm going to show you this association. So earlier what we've done, associating the vertices, but you can see there's no point where I can associate this vertex to some point, this to some point, this to some point, this to some point. So I can't select 4 different points. So the best way is to associate this geometry to different edges, or this block to this geometry, or you can say the curves to the edges. So as you can see here, 4 edges are there, but curve is the single. So I'm going to select all the edges at a single go, and this the next go I'll be selecting this curve, because this is to be mapped. All this geometry is to be mapped with this this domain, this rectangular, you can say square block. Now I'm gonna select not this one. I'm gonna select this associate edges to the curves. So I've selected. Now it is asking me to select the edges, because in the previous case we were having different curves associating with different edges, but here we have single curve. So the single curve will be associated with this with all these the 4 edges. So now all of the 4 edges are to be selected. So here you can see that it is asking me to select all the 4 these edge, select hexa edge. So I'm going to select this one, the bottom one, the right, the top one, and I'm selecting them, not pressing any control button. I'm not pressing any control button, just simply clicking over these edges with the left button. When it is done, I'll say middle button. So these 3 have been selected. Now 4th one, and I'm gonna click over this middle button. Those are selected. Now this is the next option is to select the comp curve. That means the curve. So the curves are this this domain, this geometry. I selected this and pressed middle button. So now you can see the color changes appear, and that means it has been associated with a curve, this block. Then I'm going to press middle button to come out of this selection command. Now, as I've associated this block to this geometry, that means now there's a close association with this geometry. So the best way is to now go to this not this option. I'm gonna associate these vertices also, but which point? Because the first option is to associate vertex with the points, but I don't have any point over the curve. The 4 points are required. So the best way is to, in this scenario, the best way is to snap project vertices. There is the option, this, and the second line, second row, the third option. You can see snap project vertices. So it will automatically project at the best suitable distance. So I'm going to select this one, and this is asking me select vertices to project over the left button. So I'm going to select vertices. Vertices are the intersection points of edges. That means these are the parts of the block. So that means these are the vertices. First, second, and the counting starts from 0. So 0, 1, 2, and 3. There are a total of 4 vertices. Now I'm going to select the middle button. I pressed. As soon as I press, this has projected all those the vertices, and best suitable locations have been selected, have been projected on the points. I don't need to select any point. Now I'm going to come out of this command by pressing this middle button on the mouse. Now this mapping has been done, and as I've told you earlier also, this mapping is required basically to select all of this geometry and to construct basically to construct the structured mesh. And structured mesh means a blocked mesh, or you can say the different small blocks, or you can say quadrilaterals, or you can say the rectangular mesh. Okay, so we'll be creating, and if I've associated this, so it has mapped, and I'm gonna construct rough mesh. I'm gonna say, what was the next after blocking and association? The next process was to pre-mesh parameters. To go to pre-mesh parameters, I'm gonna select different parameters. Now edge parameters selected. Now I'm gonna say select edge to set parameters. Okay, I'm gonna select this one. Any edge you can select first, you can start with, but as you can see that no second edge has been selected. So I'm gonna go to this copy parameters and to all parallel edges. Now you can see parallel edges have been selected. So I'm gonna enter some value, how many mesh count, or how many number of edges, number of, you can say divisions are to be created. So number of nodes are equal to number of divisions plus 1. That means let's say I'm gonna select 21 nodes. That means 20 divisions. So this has been selected here, and I'm gonna select the other edges. The second pair will be this one, and you always need to select edges, not the geometry. You can't select geometries. Even if you click over this, the nearest edge will be selected, so this will by default will be selected. Now I'm going to enter this 21 here also, and this is equal. Now I'm going to see how this mesh looks like. I'm going to make it on, turn it on, and say yes. So this is how it looks like, the mesh. The problem with the mesh is, yeah, you can see that the mesh has been created under this geometry. Now this block, you can turn it this blocking. I'm gonna show you this block. If I turn off, okay, Premesh, let me make it on, and I'm gonna show you that what is the problem with this mesh. This is having quadrilaterals, and you can see that this is a square kind of cell. Let me be a bit closer. So this is mapping the circle exactly the same area, and this, you can see this is a rectangle. Everything under this mesh is a rectangle, but the problem with the mesh is at the extreme, these 4 positions. You can see that this angle is a big angle, although it is having 4 arms, 4 sides. You can zoom in and I can show you that this is one side, this is other side. So that means this is one side, the other side, third one, and the fourth one. So these locations are having a great skewness. This is called skewness, means big angles or very short angles. So these are the 4 locations, and here in these cells, these may get failed. The simulations always have problems with these type of cells. So there are 4 locations. Here the mesh is very bad. This one, this one, this one, and this one. So how to, get rid of this problem? So one term, as I told you earlier, the one term is called O. I call it as O, this geometry. So the mesh will be kind of O, and that is called O-grid mesh. So O-grid, that may be some of you heard the term, but for some of you it may be new. So this O-grid, I'm going to cancel this mesh. I'm going to turn it off, just simply off. I'm going to create this block. I'm going to split this block, and I'm going to convert this into an O-grid mesh. So how do we do that? And you can see the difference in the previous mesh just I just generated, and the second I'm gonna generate. So let's see, the next mesh will be an O-grid. So we'll go under this block, not block, the second option is split block. So this split, the first one is to split block, second option is O-grid block. So O-grid means for this the suitable for this circular type of geometries. So wherever there's the circle type things. So I'm gonna select over, I'm gonna click over this O-grid block, and I'm gonna select this block. So the thing is to you can click over this block, O-grid block, and one is plus, one is minus. So this is to deselect and this is to select the block. So of course I'm gonna select over this, the first one, and now it is asking to select the block. I'm gonna click over this. Simply there's one block available, and how these two parallel you can say they having a single center. These two blocks, you can see these are not two blocks. The first, the inner one, is to show the block. Let me go under blocks, and let me right click over this, and I can convert this as a solid. So we'll show you. We just come out of this command first. Now I'm gonna select this block just to show you how this looks like. I went back and just selected it again so it can turn it as a solid. So this is a block. That means this is showing that inside this block, this is showing as a solid geometry. So this is the block, full block. This is showing a gap. There's nothing related to this gap. This is just showing that this is the block, and inside this the shaded or the solid area it is showing. It is to indicate only that this block, this is the block. Now this is asking me to select blocks for O-grid. So I'm gonna convert this block as an O-grid, and now middle button to select. I've selected, so it is created, but I'm gonna apply. It has not. This is showing me that this will be the final inner core. I'm gonna apply over this, say apply. As soon as I applied this, you can see that this has been converted into, this is turned, the single block has turned into 5 blocks. How? One is this one, second, third and fourth, and this is the 5th one. And this will help me to get an O-grid. How do we do that? Actually, let me show you what has happened. Actually, this block has converted a rectangular Cartesian coordinates into a cylindrical coordinates or circular coordinates, and these sides will act like the radial system. And because radial coordinates, you can say R coordinate, and some is theta, so this is R and this will be turning as a theta, like theta is getting increased. So the thing is that each and every radial distance is not distance, each and every radius will be parallel, it will be considered as a parallel inside a circle, parallel to each other. They're considered like that. So whenever I split this into 2, so this should also be splitted, because this will travel just like circular streamlines you might have seen that goes parallel to each other. So this is how it is done. Now it will be more clear what I am talking about. Let me show you some, let me select some edge. As we go to now, blocking has been done and splitting and all whatever. At the final stage, we're gonna go to this Premesh parameter now, and we're gonna select some edge. So now if I select this edge, now you can see that all these parallel edges have been selected. So because I've clicked over this copy parameters to all parallel edges, that means these 4 arrows indicate that these 4 edges are considered to be parallel to each other into this circular system. So any number of divisions I create over this edge, the same number of divisions will be over here, the same will be here and here also. So let's split under some specific number of divisions. Let's say I'm gonna put some number, simply random number 20. So these divisions are 20. This radial division will be 20, and all of them will be circular. This O grid that I called recently O, all of them will be, the mesh will be like an O. So let me show you how it is done. Premesh, let me make it on, turn it on, say yes. This is how you can see. Now this one, actually this should not have been done, this side, because we've already created some parameters. Let me show you how it should be looking like. I've created here 21. I should be creating only 2, so that you can see how really, I'm going to the default values here also. I'm gonna select 2 only, and now you can see, let me turn it on with only these parameters, these 4 edges. When I give parameters only to these edges, how the mesh will look like. These are O's, but you can't see right now. Why you can't see? Because I have not created this. I have not mapped up with this thing, this curve. You can't see right now. Whenever I'm gonna mesh this side, this will go up to this. This will travel. So this will have this to travel this side also. This edge, single edge, to travel this way. I'm gonna show you how. Okay, let's turn it off for some time, for the time being. I'm gonna select different edges. So that means all these parallel edges will be selected, and I'm gonna say some 21, or say not 21, just 20. I'm gonna select this was 21, 20, and again this one has 20. I've selected. Now let's again go to the Premesh parameters and see. Okay, now you can see this is what I was talking about. This is an O. Inside this is an O, again an O, everything up to here, this is an O, and this inner core is being turned into a square. So everything looks like square and no high skewness is observed. You can see everything looks like, okay, a perfect square, and or a rectangle, you can say perfect rectangle, it looks like. So even if some angle is there, but that not that much angle, that big angle, you can see. So it will be a good mesh. This is called a perfect this will be the perfect mesh for this type of geometry. Now it depends on your number of meshes, number of the count of different edges, how many numbers of divisions you want to create. So okay, now if you feel that this mesh is okay and this number of divisions, and any number of divisions will solve the purpose, you can just turn you can just go to this pre-mesh. Finally you can convert them to unstructured. This is the very important step, as I've told you earlier also in the very first tutorial. So I'm gonna click over this, convert to unstructured. Now you can see this is the type of mesh it will look like. Now I'm gonna click over this out to mesh. I'm gonna select the solver, say apply, of course, ANSYS Fluent will be using a right input. I'm gonna select somewhere in D folder, whatever you like to select, and I'm gonna create a folder saying, you know, create new. Okay, wait. I'm gonna select, create a folder. CFD tutorials, and I can say I can call it as grid mesh, or you can say circle, CIRCLE circle. Save. Now it will ask me to go to the same CFD tutorials. I'm gonna open this and say, you know, save the project .prg, and this is asking now. This is asking what which was the unstructured file you're gonna select from which you're gonna take the mesh output. So of course, by default, this is with us. I'm gonna say open. Of course, it was 2D. I'm gonna call it a circle mesh. I just typed circle mesh and say done. Okay, let's check whether this has been created or not. I'm gonna go under this CFD tutorials and let's see the circle mesh.msh file. This .msh file has been created. Let's check whether this gets opened. This is successful. This opens up there in Fluent or not. I'm gonna enter into this Fluent and say start, and I'm gonna go to this file option, read mesh. I'm gonna go into this CFD tutorials. This you can see circle. Oh, or I forgot to put this is circle. This was circle, so I forgot. So the name doesn't matter at all. So this was circle mesh.msh file. I'm gonna enter. So this is opening here. This will look like this. This will be looking like this. So this is the final mesh, and this was successful mesh. You can read different properties. You can go to this info and size. So as you can see, total of 1805 cells have been created. Total faces are 3,648, and 1,844 nodes are there. Partitions 1, because one cell zone is already there. So here also you can see that one cell zone and two face zones. So yeah, this is the final mesh. Okay, this is enough for this tutorial. Goodbye. Thank you very much for watching this tutorial.